Number 1, please explain what a misconception is as it relates to science instruction. A misconception in science is a preconceived notion or a conceptual understanding that has no basis in scientific fact. It's often deep-rooted, and some people may get defensive if they are proven wrong. There are many misconceptions in science. A couple examples are: the Earth is the center of the solar system, the planets, sun, and moon revolve around the Earth. And another one is that the trees aren't alive because they don't move. Number 2, please explain why misconceptions are important in science instruction. Misconceptions are important because challenging them encourages critical thinking. Critical thinking equals smarter populations, and the ability to think critically combats things like fake news. Please explain how you will leverage student misconceptions of common science phenomena in your future classroom to help teach those students. I will set up discrepant events like the paperclip example you showed us in class. I know that being wrong stuck with me because I don't like being wrong very much. Number 4, please explain what the term progression of the standards means in regards to the NGSS. Well, first, it's built upon the notion of learning as a developmental progression. An example of this would be in K through 2, a standard is patterns of movements of the sun, moon, and stars are seen from Earth can be observed, described, and predicted. And then it builds in grades 3 through 5 to stars range greatly in size and distance from Earth, and this can explain their relative brightness. And this builds again to grades 6 through 8. The solar system is part of the Milky Way, which is one of many billions of galaxies. And it builds all the way up into grades 9 through 12. Light spectra from stars are used to determine their characteristics, processes, and life cycles. Solar activity creates elements through nuclear fusion. The development of technologies has provided the astronomical data to provide the empirical evidence for the Big Bang Theory. So they just get more complicated as they go and they build off of each other. Number 5, please explain why the NGSS has a progression of its standards. Well, the biggest thing is it's an increasing sophistication of student thinking. Students build off of each other and the standards build off each other and connect your learning. Individual lessons are a lot like Legos. If they aren't connected to each other, then it's easier to forget or lose the information. But if we connect them to each other and use them to build up a child's knowledge base, they'll be more likely to stick through the child's life. Number 6, please explain what your role would be as a 5th grade teacher focused on teaching content related to NGSS Performance Expectations 5-PS1-3. Well, I actually use this in my unit plan for one of my lessons. The standard says make observations and measurements to identify materials based on their properties. In the unit, I said this would be great for like a mineral identification lesson. It teaches critical thought and the ability to make decisions based off of scientific observations. And my main role during that lesson would have been to provide the materials and then facilitate discussions after the exploration is finished to correct any misconceptions and make sure we're all on the same page. But most of the exploration is done by the students themselves. Number 7, please explain the desired outcome for each of the 5 stages of the 5E learning cycle in detail. Next, please provide specific examples of the types of activities one might see at each of the 5 phases in order to achieve the desired outcome for that particular stage. Well, the first E is engage, the second is explore, the third is explain, the fourth is elaborate, and the fifth is evaluate. For engage, we're supposed to hook the student with like an open-ended or a fact question, or a video if you prefer that kind of hook. Explore, you're supposed to engage with the topic, and it's supposed to be like a productive struggle. They're not really supposed to get it right off the bat, and if they do, then they already know the lesson. This is where you draw out the misconceptions. A way to do this would be like dissecting flowers and having the children don't give them where the labels should be, but give them labels so they know that they belong there somewhere, and have them try to label the flowers by themselves. The 30, explain. It's direct instruction. You reveal the answer and the concepts and terms to solidify new ideas, and that's where they can ask you questions and you can give them straight answers. This is where you would show them where the labels on the flower go. The 40, elaborate. Use their new knowledge to extend their learning and show how this applies to the real world. Try to solve a problem. The 50, evaluate, is check for understanding and make sure misconceptions have been explained. Most important for the assessment, most important for the assessment to be authentic, and this can also be part of the elaborate phase. Using the engineering is elementary version, please explain the engineering design process in detail. Use specific examples. Please explain your rationale for where in the process deep learning occurs and why. So the 5 stages are ask, imagine, plan, create, and improve. Ask, you're supposed to find a problem. So for this example, because of the declining pollination or pollinator numbers, there's no pollinators for apples. And imagine, we're supposed to brainstorm solutions. So how are we going to fix this problem? In plan, you're supposed to pick the best solution from brainstorming. For this example, we said cotton ball on a drone. Create, you're supposed to build your plan. And improve is where you evaluate the results and see how to make the best product. One way we thought we could improve, or I thought I could improve this, is to find a lower cost solution to a drone on a cotton ball. And the improve is where the most learning actually occurs, because they take all the stuff from the first 4 steps and apply it in a new way to see how they can make their product better. Number 9, which assessment did you feel was the most helpful, impactful, and why? I thought that the student misconceptions interview was probably the most helpful to me. I was in a kindergarten classroom for the first time, and I had very little knowledge about what actually goes on in their heads. So actually seeing what they had to say about what makes something living helped me get a grasp on where they were, like academically and developmentally. And plus it was also pretty funny just to see them come up with their own criteria on the fly. Number 10, which assignment do you feel was not helpful or impactful enough for me to repeat in future semesters, and why? I don't think the population education class was worth a repeat. Like, it was pretty interesting, if a little depressing, but I didn't actually learn that much about teaching. We already teach students about the impact we have on the environment, so telling them about how the population is exploding won't do much good. The birth rate in America is already below 2 children per woman, which is like the replacement rate, 2.1. So we aren't the ones contributing to population growth, and I don't think that telling children that sub-Saharan Africa and South or Southeast Asia, like telling them about how those areas are raising the population worldwide, won't do any good, because it's not something we can fix. So I probably wouldn't repeat that.